we have two capacitors, C1 and C2, and they are connected with a switch and a resistor. And at time t equals 0, C1 is charged to some voltage V0, and C2 at time t equals 0 has voltage equal to 0. And we need to find out what the final voltage is and the energy lost in the process, because what happens when the switch is closed is that current will flow from C1 to C2 through the resistor. So current will flow from C1 to C2 through the resistor, and as it does that, it will charge C2 to some final voltage. I'll call that for right now V2 final, and C1 will be left at some final voltage, V1 final. And as the current flows, some of the energy will be dissipated through the resistor. Alright, so let's first find the initial energy stored in the circuit. Capacitor 2 stores no energy because its voltage is 0. Capacitor 1 has all the energy, and it would be 1/2 C1 V0 squared. So that would be all of the energy. We also know that initially, with capacitor 1 being charged, the charge on capacitor 1, Q1, equals C1 V1, and at time t equals 0, Q1 equals C1 V0. Now, there's no external source on this circuit, and so there's no place for any more charge to come in. And so our total charge has to be Q equals C1 V0. That's the only charge we've got. So that charge, when we reach our steady state, will be distributed across both capacitors. And so when we reach our steady state, I'll call that Q1 final and Q2 final. Q1 final plus Q2 final has to equal that original Q, because there is no other place for that charge to come. So it has to be there. Alright, we also know that Q1 final has to equal C1 V1 final, and Q2 final has to equal C2 V2 final. That's just the definition of capacitance. Now I'm going to add these two equations together. And when I do that, I get Q1 final plus Q2 final equals C1 V1 final plus C2 V2 final. Let me copy that. So Q1 final plus Q2 final equals C1 V1 final plus C2 V2 final. Now remember, Q1 final plus Q2 final just equaled our original total charge Q. So that's Q equals C1 V1 final plus C2 V2 final. Now take a look at our circuit right here, and notice that when time reaches infinity, the current doesn't flow anymore. There's no more current. And so if no current is flowing, then everything here has to be at the same voltage. So that's all at some final voltage I'll call VF. Everything down here is going to be at voltage 0, that's at ground. Since no current is flowing, the positive terminal of C1 and positive terminal of C2 have to be at the same voltage because they're connected. And so V1 final has to be the same as V2 final, and we can just call that V final. That's the same for both of them. So I can now say that Q equals C1 V final plus C2 V final. Now I can factor out that V final. So Q equals V final times C1 plus C2. We also know from over here that Q equals C1 V naught. So C1 V naught equals V final C1 plus C2, or V final equals C1 plus C2 over C1 V naught. No, I got that backwards. V final equals C1 V naught over C1 plus C2. So our final voltage equals C1 V naught over C1 plus C2. So our final energy is going to be the energy from both capacitors. So U equals 1/2 C1 V1 squared plus 1/2 C2 V2 squared. Well, V1 and V2 are the same, so our final energy is 1/2. Factor out that V final squared times C1 plus C2. Or our final energy is 1/2 VF, right here, C1 V naught over C1 plus C2 squared times C1 plus C2. Or I can write this as 1/2 C1 V naught squared over C1 plus C2 squared times C1 plus C2. And then that cancels with one of those. Or my final energy is 1/2 C1 squared V naught squared over C1 plus C2. So that is my final energy. So how much energy was lost? Well, our initial energy was 1/2 C1 V naught squared. And so our final minus initial, 1/2 C1 squared V naught squared over C1 plus C2 minus 1/2 C1 V naught squared. So this is the amount that's lost. So this is delta U. That's the amount that's lost. And if I factor out a 1/2 C1 V naught squared, I'm left with, from this first one, I have C1 over C1 plus C2. And then from the second one, I have minus 1. And then if I get a common denominator, 1/2 C1 V naught squared, C1 over C1 plus C2 minus C1 plus C2 over C1 plus C2 equals 1/2 C1 V naught squared, C1 minus C1 minus C2 over C1 plus C2. And then C1 minus C1, those cancel out. And I get minus C2 over C1 plus C2 times 1/2 C1 1/2 C1 V naught squared. So my initial energy was 1/2 C1 V naught squared, and then I lost C2 over C1 plus C2 times 1/2 C1 V naught squared. So I lost the fraction of energy that is equal to this ratio right here. So, like for instance, if C1 was, let's say they were the same. Let's say C1 was 2 Henry's, farads. C1 is 2 farads, and which is very big, and C2 is also 2 farads. Then that fraction would be 2 over 2 plus 2, or 2 over 4, or 1/2. I would have lost half the energy. And so if my two capacitors were identical, I would lose half the energy. Otherwise, I lose some fraction of it based on the ratio of C2 and C1 plus C2.